Hello and I welcome you in this video. Today we are going to discuss ionic equations. Now, an ionic equation is an equation that only shows the ions that are actively involved or are participating in a reaction. Now, for you to be able to write an ionic equation, you are supposed to have known how to balance molecular equations. So that one I'm going to refer you to my previous video on how to balance chemical equations. Then you are going to see how you can be able to balance molecular equations very easily. As for today, we are going now to be looking at how to write ionic equation from already balanced molecular equations. Now our first equation is here. And it is an equation between sodium hydroxide and dilute hydrochloric acid to produce sodium chloride and water. Now, for you to be able to write ionic equations, you are supposed to first of all know the correct states of these reactants and products. Now, as you can see, we have sodium hydroxide as aqueous, hydrochloric acid as aqueous, sodium chloride as aqueous, and water as a liquid. Now, aqueous means that these compounds here are soluble in water. When a substance is in solid state, even if it is put in water, that substance means it is insoluble. Now, for you to be able to know the salts that are or compounds that are soluble, you need to know these rules are called solubility rules, which shows that all sorts of sodium, potassium, ammonium are soluble, all nitrates are soluble, chlorides are soluble apart from silver, chloride, and so on and so forth. So you need to really have a look at this table for you to be able to know this quite easily. Now, in our equation here, we have sodium hydroxide, which is soluble, HCl, which is soluble, and sodium chloride, which is soluble. Now, for us to be able to write ionic equation, we are going first of all to write this one in the original form from the original ions that formed this sodium hydroxide, and those ions are sodium and hydroxide ion, like that. Sodium ion and a hydroxide ion. So these ones are going to substitute this one there. So we have a sodium ion there. Remember to put your aqueous sign there. Then we have your hydroxide ion there. Remember to put your aqueous sign like that. Then we're going to move this one now towards this side. Then we have your hydrochloric acid here, which is also in water and is soluble. So the original ions, so we can add our positive sign there. The original ions that formed this compound are hydrogen ion and chloride ion. So we are going to substitute that one there with the hydrogen ions. Remember to put your aqueous there. Then plus chloride ion like that. Remember to put your aqueous sign there. To form, now this is sodium. This sodium chloride originally was formed from sodium and chloride ions. So we are going to substitute that one. Remember to put that one there. Plus a chloride ion. Remember to put your aqueous there. And finally, plus your water. Your water, remember, is a molecular compound. It cannot be, it's just a liquid, it cannot be aqueous or liquid. So now this is our equation now written in form of the ions that formed these compounds. Sodium hydroxide formed from sodium and a hydroxide ion. Hydrochloric acid formed from hydrogen ions and chloride ions. Sodium chloride formed from sodium ion and chloride ion. Water is a molecular compound that is not an ionic compound, so we're not going to write, it's going to remain like that. Now, from there, what we do for us to be able to write now an ionic equation is that we are going to look at now the ions that are on this side that are similar to the ions that are on this side of the product. And we remove those ions. We have sodium on this side, and we also have sodium on that side there. We remove from that equation. This means that these ions now, which are not taking part in this chemical equation, are called spectator ions. On this side now, we have also a chloride ion, that one there. You remove it because we also have a chloride ion on this side there. You remove it. So now you are left with water like that. You now remove, take our equation back there. So you are left with water like that on this side, and this side you are left with hydroxide and hydrogen ion. Now, as you can see now, these are the ions that were actively involved in this chemical reaction for them to produce now water. Now, these ions here, sodium chloride ions, these ones that we are seeing here, these ones are the ones that we call spectator ions. They were not actively participating in this chemical reaction. Thank you very much for watching that video. We are going to continue looking more on ionic ions. We are going to understand how to write these equations, and more so, we are going to understand more on what we mean by a spectator ions. A spectator is just spectating. It's not actively involved in that chemical reaction, but we have the action that we have the ions that are taking part in that reaction, as we have seen from that reaction. Thank you very much for watching this video. Remember to subscribe. We are going to upload more video on this topic here. We'll meet in the next video.